Hello everyone, I'm Stefan Šošić. I am CEO at Bicility, and I am thrilled to welcome you all to my session here at DynamicsCon Virtual with a session Telemetry Unleashed from Basics to Brilliance in Business Central. As a first-time speaker, I'm incredibly grateful for fantastic feedback and overwhelming support that I got this session chosen among many others. Thank you for joining me today as we embark on a journey to harness the full power of telemetry. In this session, we will start by exploring the essentials of the telemetry, what it is, why it matters, and how it works within Business Central. We'll then move to some more advanced techniques, real-world examples of how telemetry can drive smarter business decisions, enhance operational efficiency, and ultimately lead to more connected and responsive business environment. By the end of the session, you will have comprehensive understanding of how to implement and leverage the telemetry to transform the data into actionable insights. Let's unleash the brilliance of telemetry together. So, before we begin, I encourage you to ask any questions you have in the chat. I will be keeping an eye out for most interesting ones, and we will address them at the end of the session. So let's start by following 3 simple steps how to enable telemetry. So telemetry can be enabled basically in 3 really simple steps, starting by setting Azure application insights, then configuring Business Central to use application insights, and at the end, verifying the collections of signals in application insights. So first, head over to your Microsoft Azure portal. There in search bar, you need to type application insights and select it from the results to open. Once you have opened application insights, click on the create button to set up new application insights resource. A new page will open up where you will need to fill out basically the details for your new application insights resource, including your subscription information, the name of application insights instance, the region, and other information. After you filled out everything, you can proceed to review and create your application insights. In your newly created application insights, focus on the connection string. So we will be needing that part to extract from the beginning of instrumentation key up to semicolon. With our connection string in the hand, we can move to the second step, for which we need to move to Business Central admin environment, and you can access the admin environment on 2 ways, either using the GUID or tenant name. So upon opening, by default, it will show up environment section. So there you will need to click on environment, which you would like to enable telemetry signals. If telemetry is not set, it will display as not set, and you will have option define to proceed. So click on it. It will open on the right side new sub page where you will need to enable telemetry and also put your application insights connection string, which we already got previously in the step. After enabling and inputting the connection string, your logging telemetry on environment should look like this. You save it, and then the final step is to confirm whether the setup was completed accurately and ensure that telemetry signals are being received. So in order to perform this check, we will be navigating back to our Microsoft Azure portal and accessing newly created application insights resource you created, and we are proceeding to logs page. After proceeding to logs page, you will have the new query editor, and in the input box of the new query, we will input traces. By running basically this query, it will display any received queries received for your environment. And that's it. Basically, in those 3 steps, you already have your telemetry running smoothly and started receiving signals. So what are these results showing? Essentially, we are collecting the telemetry at 2 levels. So application insights on environment level and on extension level. So on an environment level from core Business Central environment, and as extension level, we are meaning to third-party extensions. So either the original telemetry for those extension, or even the custom telemetry signals which could be written by third-party extensions. So what do you get? What will you take away from this session? By the end, you will have comprehensive understanding of how to implement and leverage Business Central. You will know how to set up application insights, configure Business Central to use it, and verify that your telemetry data is being collected accurately. You will also be able to analyze the results and gain valuable insights from both the environment level and extension level telemetry. In the upcoming slides of this session, we'll cover also the creation of advanced elements, which you can use for your dashboards, providing you with additional insights and capabilities to enhance your visualization experience. So directly from this dashboard created, you can immediately see if some signals spiked up and act on those very fast. It's important to be mindful also about unexpected costs. Unexpected costs can arise if there are too many telemetry signals, leading to increased expenses for telemetry logs. Efficient monitoring and management of these signals is basically crucial to prevent escalating costs. In the Business Central, it provides 5 gigabytes of free telemetry data per month. To avoid exceeding this limit and avoiding unexpected charges, it is advisable to set the daily cap at 160 megabytes per day. Then telemetry events typically range from 2 to 10 kilobytes in size, which translates basically to a total of 5,000 to 80,000 events per month. By using an average size of 5 kilobytes, you can manage up to 32,000 events per day within the 3 gigabytes allocation. This approach helps in efficiently monitoring the system performance while keeping the costs under control. So let's move to the daily caps. To manage basically daily cap, you can start by navigating back to your Azure Insights resource, and from there go to Usage and Estimated Costs section. Clicking on Daily Cap action, it will open a sub-page on the right side of your screen. You can there fill basically your desired daily limit. In this example, we'll set 160 megabytes or 0.16 gigabytes per day, which aligns with our free plan. If this limit is reached, you will receive notifications such as shown on this slide. so that resource has exceeded its daily cap within last 2 days. So to avoid basically receiving these notifications, we can set some data collection rules, which I will explain basically in the next upcoming slides. So let's talk about what happens if you want and need extra data. Once you exceed the free 5 gigabytes, it costs you around $3 per additional gigabytes. This translates around 100,000 events per month, or roughly 3,300 events per day, and it is essential to plan your budget accordingly and focus on collecting the most valuable and insightful data. By doing so, you can ensure that you are maximizing return of your investment while keeping and maintaining efficient and effective telemetry practices. So managing your telemetry data within the 5 gigabyte limit requires filtering out high volume sources. Significant data can come from web service calls, background sessions, and other noisy data, which should be basically identified and excluded. Why it is necessary? Most important is to filtering ensures basically the cost efficiency by reducing unnecessary data and allows you to focus on essential information. This process leads to better insights and more informed decision making. By cutting out the noise, you ensure that your analysis is both relevant and manageable. So you are receiving much signals. How come to that? So here we are having a visual representation showcasing how telemetry investment areas have evolved across different versions of Business Central. This illustration offers valuable insights into where Microsoft focus and resources have been directed over time. So in the beginning of 2019, we had just two signals from long-running operations and authorization signals. And then by each version of Business Central, those signals expanded. So as Business Central evolves, so does the volume of telemetry events generated. In this slide, we can see the graph showing comparing versions. We have seen the steady increase. Starting from BC 19, we started around with 1,670 events. Then comparing that with just two versions ahead, we see the increase of 300, roughly 300 events. And then with just two versions ahead more, we seen the increase of 200 events more. So it is basically very crucial to filter out the signals to maintain basically the efficiency. While we are working with Azure settings, let's talk about tweaking out data collection rules. These rules act as filters for our telemetry data, allowing us to select which events to include or exclude based on specific criteria. By controlling the type of telemetry data that is collected and sent to Azure Application Insights, we can efficiently manage the volume of data and keep the relevant signals and costs under control. In order to set these rules, we will go back to Application Insights, which we created and connected to our Business Central environment. And we will need to click on the workspace link on the right side on the Application Insights resource page. Then we will navigate to the Tables page. And here we will be focusing on app traces. There it is place which is where your telemetry signals are stored. Next, you will need to click on three dots on the right side and then select Create Transformation. This will open up AppTrace's transformation page. And if you don't already have an existing data collection role, you will need to create one here. So upon going to the next and creating the data collection rule, AppTrace's transformation will show up, showing up the table with all signals non-filtered. So we will go to the transformation editor. And in transformation editor, it is time to craft our query to specify what we want to filter out. This step is really crucial as it allows us to define the criteria for excluding specific events or data points from our telemetry. In the following slides, we will see which signals should be filtered out to ensure basically efficient data management and cost control. In this case specifically, we have just filter out based on event ID, RT818, which shows long-running queries. We cannot save this transformation until we run it. Then we will have the table filled out with the data if existing. And then only then we can see that apply button showed up as blue and we can click on it. So let's decide which signals to limit. So this process involves prioritizing critical events and considering their business impact. By filtering out the noise, we maintain the clear, relevant stream of data that supports meaningful analysis and informed decision making. So as we review our telemetry, signals which capture authorization succeed, logs from web clients exclusively, those are candidates for exclusion to prevent record overload. Additionally, events associated with incoming and outgoing web service calls for specific publishers may contribute to large API activity and could be also considered for removal. Expanding our review, signals for capturing error dialogues with empty text may also not align with actual errors and could be excluded from the logs. Similarly, additional events shown on this slide that are representing various system activities like posting previews, job queue, lifecycle events, email sends, and task creation can be excluded if they don't meet your telemetry goals. By filtering out these signals, we ensure that telemetry data remains focused for decision making. On the next slide, we see the query, which serves as an example to exclude specific events based on their event ID, ensuring that only relevant signals are present in our telemetry data. By implementing this, we can streamline our telemetry to focus on crucial insights, making our data analysis more efficient and actionable. For app page view rules, there isn't much to filter out. However, we focus only on signals from production environment. We need to use similar information from measurements. Although the environment type property doesn't exist in this table, it is available in measurements, and with 0 representing production and 1 as representing the sandbox environment. In the previous slides, we have covered the essential telemetry signals that should be filtered out. However, every telemetry signal is thoroughly documented on Microsoft Learn, providing a valuable resource for further investigation. So this will help you determine if there are additional signals that you might want to exclude. Now, let's deep dive into capabilities of KQL, or Kusto Query Language. So KQL offers powerful querying capabilities characterized by its straightforward syntax, extensive range of operators, and impressive scalability and performance. So these attributes, among others, contribute to its effectiveness in handling data queries efficiently. To write one useful KQL query, basically you will need to go through 4 parts. First part is where, then we proceed to project, extends, and render. So we will cover all these 4 parts in upcoming slides, starting from first part, or where part. So the where statement in KQL is used to filter rows in dataset based on specific conditions. It's similar to the where clause in SQL. Here is a detailed look how you can use the where statement in KQL, especially for telemetry in Business Central. Its basic syntax is highlighted green here with the keyword green. And for the condition part, you can use various operators to define your conditions. We will see now some examples. So some examples will be by filtering by timestamp to filter telemetry data to only include entries from for example, last 7 days, then filtering by specific value, as we mentioned earlier, so to filter out by some specific event ID. You can also combine multiple conditions into one where statement by using AND operator. So here we will be then combining basically timestamp filtering with event ID filtering. You can use also in operator, which comes pretty handy, especially for the event IDs, where you can define the list of event IDs to which you would like to focus and filter the data. Some practical examples, or most used from the practice, which I really often see, is to filter by, of course, event ID, then filtering out by environment type. As we said, we just want to get the signals from the production. And if you didn't set it up in the data collection rule, you will have to filter it out by writing the KQL query with where statement. Then filtering by checking lstack trace. Lstack trace contains a lot of data. It also contains, for example, object ID. So if you say contains object ID, for example, so you will focus the signals on a specific object ID in that query. Next examples are by filtering by, for example, Azure tenant ID, extension version, or AL object type. Those informations are all gathered in custom dimensions. So here, especially for Azure tenant ID, you will need to do also some conversion to string, and then to filter out the traces accordingly. The next part of KQL query is to limit the number of columns, and for that we will be using the project statement. So the project statement in KQL is used to select specific columns from dataset, and you can optionally rename them. This is particularly useful when you want to focus on certain aspects of your telemetry data in Business Central. Its basic syntax is following with a keyword highlighted green, or the project. Then you define the columns. And if you want to rename some of the column, you put on the left side the new column name, then equals the old column name. And then you will have the new column name, which can be used further on. Practical examples, again, in practice, how this part of KQL query is most used is to have basically long expressions shortened. So if you want to have company name, instead of writing custom dimensions dot company name, you can just define like project company name equals custom dimensions dot company name, and below that point in your KQL query, you can just use company name as expression. So you would not need to define the whole expression from where it is got. So there are more examples, most commonly used, like Azure tenant ID, environment name, environment type, company name, and so on and so on. So let's move on to the third part of KQL query, and that's basically adding new columns. Statement which adds new columns is extend statement in KQL, and it's used to create new columns in your dataset by computing values based on existing columns. This is particularly useful for adding derived metrics or transforming data to suit your analysis needs. And the basic syntax for it is with keyword extend, then the new column name, and equals the expression. So you can use various expressions to define new columns, such as arithmetic operations, string manipulations, or functions, which we will show on practical examples. And here we are getting, in first example, extension version. So if we want to get extension version as a new column, we can parse it from the custom dimensions, convert it to the string, and store it in the new column extension version. Same goes to execution time. Just in this case, we need to do conversion to time span, and then store it into new column. And in third example, with extend, we defined the new column, which is basically rendering time in milliseconds by dividing the total time in milliseconds by server execution time in milliseconds. So let's move on to the fourth part of KQL query, which is some of the most important part, a key part for basically all the users, because the render statement in KQL is used to visualize query results in various chart formats. So this is particularly useful for creating dashboards and reports to monitor telemetry in Business Central. So without this part for rendering the charts, it will have only the signals or the data stored as table records, which is not really user-friendly. So you would need to render it and visualize it, so you can easily see the difference, comparison, or even signal spikes directly from your dashboards. Basic syntax is with keyword render, and then by defining the chart type. So you can specify different charts, such as column chart, area chart, bar chart, pie chart, and more. But we will focus in the next slides on these 4 charts. So to visualize counting events over time as a line chart, so we are using keyword render, then specifying type of chart, which is in this case column chart, and then specifying the parameters. In this case, for column chart, we are needing the legend, which we can show or hide, define X and Y title among the main title. And when we run this render, how it will look like. So we will get visualization by columns like this. So it is pretty useful to filter out, for example, like in this example, by long running queries. So you will see procedures which have been run for a long time, and in comparison with other procedures which took less time and less time and less time. And in this case, it is by versions of your extension. You can also visualize the count events over the time as an area chart. It has slightly different parameters. So the parameters here added are accumulated true and kind stacked. So what does that mean? Those parameters are basically specifically for area chart, so you can tweak it around to get desired look of your chart. But how that chart looks when we render it out is basically compared view of spikes. So most commonly, from what I saw it being used, and I personally use it to compare between different extension, and then we will see which extension has the most spikes or long-running events by extension. Then we can move on to rendering the bar chart. Bar chart has parameters different from previous ones. So we will define X column, then X title, Y column, Y title, and we can display a legend, but in this case, I left it as hidden. And when I run this part of render, we can get the rendering like this. Especially useful when you want to show the top results. So in this case, top 10 execution time of the functions. So it provides clear overview and comparison between the records. And fourth, the last rendering which we will show here is the pie chart. It has the same parameters as column chart, so legend, XY title, and main title, and also commonly used. But yeah, you can choose whether you want some of these charts on your dashboard. Here is just an example of same query being displayed as pie chart. So long-running queries by version. Now that we have rendered our query, so we've written our KQL statement, filtered it out, created new columns, and then at the end rendered to desired chart that we want, we can move on how to add it to our dashboard. In order to add your query to dashboard, we can go to Application Insights on your Microsoft Azure portal, then move to Logs page, and here first you will need to craft your query. Like I said, from the traces table, you filter out by where statement, then extend by some columns, use project to define new columns, and at the end render. So in this case, I rendered it by long-running queries by function name, and after you run it, you're satisfied with the result and basically how it looks. You can go navigate to your upper right corner, click on pin 2, and then click on Azure Dashboard. By following these steps, you have added your query to the dashboards. And if you want more samples, so didn't want to include much more samples in this presentation, but they are available officially. So you can visit aka.ms/bc telemetry samples and explore extensive telemetry examples and best practices in the following resources at the link. So now, when we covered most of the stuff, let's check alerts in the telemetry. By setting up alerts, you are essentially putting your Business Central telemetry on autopilot. This ensures that you never miss a crucial update or issue, maintaining a really smooth and efficient operation without the need for constant manual checking. So once alerts have been defined on your Azure telemetry, they will automatically notify you. So what are the alerts' key features? So alerts are basically real time savers because they allow us to set and forget basically about the telemetry until a notification pops up. So the big advantage is that we receive notification instantly without basically to check daily for the updates. So without the alerts, you will go daily on your dashboard. Then if you have created, of course, the dashboard, then see the results of your charts and analyze them. Or you would go to logs and then write the custom queries. So that pretty much takes a lot of time. But with alerts, our system is under 24/7 surveillance, drastically reducing the possibility of human error, since by checking the dashboard and writing every day, running the queries, you can not see basically some small detail which could lead up to you not acting on time. So this means that we can, with alerts, detect problems really early, even before even customers notice them, and react really quickly on it. So constant monitoring through data-driven decisions, it really helps us to identify the patterns and the trends that something's that's tough with periodic manual checks. So before setting up an alert, it is essential to identify which signals are the most relevant for your organization. So this differs whether you are ISV or VAR. So if you are ISV, so your focus will be mostly to app source validations, since they are particularly crucial as they ensure the reliability and compliance of their solution. For VARs, job queue errors and error dialogues are more important, focusing on operational efficiency and basically the troubleshooting. But however, some signals like database performance are universally relevant and crucial for both ISVs and VARs. So by understanding these distinctions, we can tailor our alerts to efficiently monitor what matters the most. So basically, you will need to go to the Microsoft documentation, check the signals, and determine which signals are basically from your benefit. When you do that, we can move to crafting basically the query. So from the traces, we written here the example query, which is for analyzing failed job queues. To tailor this for real-time monitoring, you will need to modify the timestamp to reflect basically just the last hour. Once adjusted, create an alert using the action on the top upper right corner. There is new alert rule action. So this action ensures you are immediately notified of any failures, but you will need to fill some data in upcoming window. So in this window, we will configure basically the frequency of alerts for new telemetry data to align with our queries, starting from the measure, table rows, aggregation type, aggregation granularity. So I said 1 hour, and basically you can set that even to smaller gaps, higher gaps, according to your needs. But in the section alert logic, you can define threshold value and frequency evaluation. So again, it is 1 hour, and you can see it is an estimated cost based on that configuration. For instance, with application insights, setting up alerts to receive notification every hour costs approximately $50 per month. So you can tweak out this property, frequency of evaluation, to less or higher according your budget. But of course, with setting it to less and less, and if you have many alerts, it could cost you more. But this is still very cost-effective setup, which ensures you are promptly informed about any crucial updates at very low cost. So after this, in the final tab, you will select how you want to be notified about your alerts. So in the notification, you can choose options like receiving the notification through email, Azure mobile app, SMS, or voice. So customizing these settings ensures that alerts are basically delivered in a most convenient way for your team, enabling timely responses to critical telemetry data. So by getting alert, notifying it on time, you can act basically on time before even reaches all customers. So the damage is pretty low, instead of manually get the support case and then investigating the data and fixing the issue. So on this way, we are one step ahead of preventing an errors and resolving those. So we have reached basically our end of the session, and I want to thank you all for your time and attention, and feel free to ask any questions in the chat. I will bring them up and answer them.